Welcome back, mathematicians. In this video, we are going to look at the graph of sine. So let's start with the graph of sine and identify some of the attributes of the graph before we move on to the equation that produces this graph. So first, what we notice is that the domain is the set of all real numbers. Now, I know that I have a certain window here, but it is supposed to be indicated that this does go to positive infinity and negative infinity, so we would include arrows to indicate that. So the domain is the set of all real numbers. We also notice that the range consists of all real numbers from -1 to 1 inclusive. So the maximum point is going to be this point right here, and the minimum point will be this point right here. And of course, it's actually going to have infinite maximum points and infinite minimum points as it continues in the same pattern to infinity and negative infinity. So that's why we can say that the range consists of all real numbers from -1 to 1. In interval notation, we would represent this as -1, +1 with brackets. The amplitude is the height from the center line to the maximum or minimum. So I've heard this called the center line. I've also heard this called the midline. So in this case, the center line or midline is actually going to be the x-axis. It will not always be the x-axis if we have a transformation that moves it, but in this case it is the x-axis. So that amplitude is going to be this distance right here from the midline or center line to the maximum, which is a distance of 1 unit, or from that midline or center line to the minimum, which again in this case is going to also be 1 unit. The period is the length of one cycle of the curve, and the fundamental period, meaning the period for just the sine function with no transformations, is 2 pi. So we can see that in this particular graph, we can look at a cycle as starting at 0, 0. It then goes up to this maximum, curves back down to another x-intercept at pi, 0, curves down, decreases down to the minimum, and then increases up to another x-intercept. And at that point, it stops, or it's done with its first cycle or period, and then it continues on to another cycle or period. So it continues to repeat, which is why we consider these graphs periodic. They're going to repeat themselves infinitely. And so what we're looking at here is one single period or one single cycle. The length of this cycle is, again, 2 pi, from 0 to 2 pi. This will not always be the case because transformations could change this. But for the basic sine function, or you might even call it parent function, it is 2 pi. Let's now look at the equation for sine that produces the graph. And you'll notice I've got a couple variables here that will result in transformations of the graph of sine. There is one transformation I'm not going to include today because this transformation will be included in a separate video, and that would be a horizontal shift. So we're going to start with A. The absolute value of A is the amplitude. If the absolute value of A is greater than 1, it represents a vertical stretch. And if the absolute value of A is less than 1, it represents a vertical compression. Okay, so again, absolute value of A is the amplitude. So the sine of A does not dictate the amplitude. If A is negative, it has nothing to do with the amplitude, and we'll get to that in a second. The period is going to be T, which is equal to 2 pi divided by omega. So you'll notice you have the variable omega, and so you'll have some value for omega in your sine equations, and so you'll replace omega in this equation and solve for t. This value, this t, represents the period. So if omega is larger or less than 1, then your period will no longer be 2 pi, which means what you have is a horizontal stretch or compression. If omega is greater than 1, it's going to represent a horizontal compression. And if omega is less than 1, it's going to represent a horizontal stretch. I know that seems counterintuitive because you would think a greater value would represent a stretch, a lesser value would represent a compression, but it's actually reversed because what you're doing is taking the fundamental period and you're dividing it by that omega, which is why it's the opposite of what you normally would think. Then we get to a reflection. So it's possible to reflect these, and it goes back to A. So if A is less than 0, meaning that if A is negative, it represents a reflection with respect to the x-axis. And then finally, we have a vertical shift. So this value of B on the very end of the equation is a constant, and it represents a vertical shift. If B is a positive value, it's going to shift the graph up. If B is a negative value, it will shift the graph down. Let's now use that information in order to graph this equation. Let's start by picking out all the attributes of the graph, and we'll start with the amplitude. So we know the amplitude is absolute value of A, which is equal to 3 in this case. We want to then find the period, and remember the period is equal to 2 pi divided by omega. Omega in this case is 2, so it'll be 2 pi divided by 2, which is equal to pi. So this represents a horizontal compression of the period. No longer is it at a distance of 2 pi, but now it's a distance of pi. Again, that's a horizontal compression. The last transformation that we have in this problem is a constant of -1, which as we discussed represents a vertical shift. So this has a vertical shift down 1 unit. Going back to the amplitude, I do want to emphasize that since the absolute value of A is equal to 3, which is larger than 1, this does represent a vertical stretch by a factor of 3. So if you're familiar with transformations from your algebra course, they're really the same transformations, just labeled slightly different in a trigonometry course. Now let's take this information and plot the graph of the sine function. I'm going to start with the most basic sine function, which is y is equal to sine of x. I am going to color code these and label them as numbers 1, 2, 3, etc. to let you know the steps I'm taking. But I'm color coding them because otherwise it would get to be a lot of points on the graph and it would maybe be confusing to see which one corresponds to which part or step of the process. So if you're looking at sine of x, what I know is that it starts on 0, 0. It's got a maximum at pi over 2, 1. Then it goes to an x-intercept at pi, then it goes to 3 pi over 2. And while it continues on in that pattern forever, I am going to stop right there. Actually, sorry, I'm going to keep going to 2 pi, 0. So you should have 5 points for one complete cycle or period. And so I am going to stop right there, although again, it does continue on forever. Now, this is just something that you kind of learn over time is a pattern. So sine, you're going to start with the origin, then go up to 1, down to the x-intercept, down to the minimum, and then back up to the x-intercept. For number 2, I'm going to apply the period change, which means I have a horizontal compression. So I'm going to do the horizontal compression, which means that the period is now going to be pi units. So what I'll do is start on the origin again, but what I recognize is that I will conclude the cycle or period at pi units instead of 2 pi. What this means is that halfway through, I should have another x-intercept, which would be pi over 2, because remember I've got 3 x-intercepts. Then I know that the next point after 0, 0 is going to be a maximum, and then the point between the two other x-intercepts will be a minimum. So again, this is about patterns, but it's also about starting with the origin, then plotting the endpoint of the one cycle, and then from there going to the midpoint as your other x-intercept, get your maximum and your minimum, and you've got your 5 points. So now we've successfully graphed with a horizontal compression, and we have now a period of pi. Next, what I would like to do is apply the amplitude or the vertical stretch by a factor of 3. So I'll call this step number 3, vertical stretch by a factor of 3. So what this means is that the maximum and minimum values will change, outputs will change, but the x-intercepts will remain the same. So my x-intercept at 0, 0 remains the same. Basically what you're doing is taking all of your outputs and multiplying them by 3, which is why the x-intercepts will remain the same because they are on the x-axis, which has a y-coordinate of 0. However, this maximum here has an output of 1. I'll multiply that by 3 to get a new maximum of positive 3. X-intercept stays the same. The minimum has an output or y-coordinate of -1. I will multiply that by 3 as well and get an output of -3. And again, the x-intercept stays the same. So now I've graphed this new transformation, and the last transformation I'm going to plot, which I'll do in my green color, is going to be the vertical shift down 1 unit. So I'll just call that shift down 1. So I'm going to go ahead and take all of my points, every single one of them, and shift them down 1 unit. And this will give me my final version. So here I have my final version in green, and because I've got those 5 points, I can actually continue on to more points to include more points or more cycles of this graph if I wanted to. And so what I'm going to do is go ahead and connect this with a smooth curve. And there we go. And so that is the graph of y equals 3 times the sine of 2x minus 1. All right, guys, good luck.